I'll kind of show you what I'm going to ask you to be doing here. So here I'm opening up a text editor on a Mac. Okay, so I don't, well, and then now, see, if you're on a Mac, it comes up in this rich text format thing, and so you want to make it a plain text, otherwise the code doesn't like it. So I'll write the program. Now, in the book has something kind of similar, and what they do is they have you put it in something called the unnamed package or the default package, and that's a state of sin in Java programming. So every Java program must go into a named package. What's that about? You'll learn all about that. But nevertheless, the very first line in every one of your Java code is going to be package and then a name of something. The other thing is that, and I'll review all of this, but is that everything in Java is in a class. Okay, bless you. What is it? What is a class? Again, we'll cover that, but generally the first line after the package is something called public class and then the name of the class. And there are conventions about what these names are, which we will all go into. And now you all know what functions are, but in object-oriented programming, functions are called methods. Why are they called methods and not functions? Because methods are associated with a class. In other words, in Java, there is no such thing as a function. A function is just something that's kind of out there. In Java, everything is associated with a class. So, okay, so what I have done is I have created a method in my class, which I'm calling Hello CS2173. What do all these mean? Again, we will cover public, static, void, main. Now that particular sequence of names tells the Java virtual machine where to start. In other words, in a program, you say, well, where do you start? In Java, it always starts with this particular method in a class which you direct it to. We'll see how that works in a second. And the very first thing that we typically do is do a print. Now, let me make this bigger for you. Ooh. Okay. So now, in Python, if you want to print something, you say print, and then, so easy zippy. In Java, you can't do that. Why can't you do that? Well, because print is a function, and Java doesn't have any functions. So how do you do something? Well, you have to do a lot of extra typing. So in this particular case, there is an object called system.out, and it has a method called printline. And so if I want to print something, I got to do a little extra typing. And now the Python people are saying, man, that is a lot of typing. My fingers are hurting. I do that. So okay, so that's the program. That's the first program. Let's see, I did have an extra one there. All right. So, all right. Now here's the other thing that's different about Java from most other languages. The name of the file that you save this in has to be the same as this class. That's something that they introduced. I don't know if they were the first ones to do it, but in most other languages, you can call the file anything you want, and it doesn't have to have anything to do with what the class name is. In Java, they said, well, that can make it hard to find stuff. So if I want to know what the name of the file that this class is in, it has to be hello cs2173.java. That can't be anything else. And if I see a file called hello cs2173.java, and I want to know what the class is inside that, then it's the name of the file. So that's kind of nice. So the other thing is that, you see, we're up here where I said package, and I said CS. Notice that CS is lowercase. We'll get into all of that. But the code, the file in the code must be in a directory of the same name as the package. So basically what that means is if I see code like this, I know what directory it has to be in. Now it can be kind of deep in my file system somewhere, but I know that the directory that this class has to be in has to be called CS2173. And so when I save it, that means I have to name it the right kind of thing. So let's, now I'm going to put it in a directory called, I think I called code. I'll put it called code, but now I want to put it into another subdirectory, and I need to name it CS2173. And now I need to name this hello cs2173.java. Okay, so all Java source code has the extension .java. And so where is this located? Let's find it. Okay, here's what I just created, and here's the directory, and there's the code. Now, how do I run that? Well, again, now our IDE is a text editor and the command line. So on a Mac, it's a terminal app. On Windows, there's the CMD. They also have PowerShell, whatever. I don't know how to use that. Again, I'm a Mac guy, as you could tell. But I need to change my directory to not where the code is, but actually a directory right above the one where it's in. And so here's like a little trick. This works on Windows too. You can kind of drag it in, and it'll go. You know that trick. I think on Windows, from the File Explorer, if you drag it into the command line, it'll take you to where you are. So just to make sure we're there, and now here's the one thing you want to check to see whether Java is actually available on the terminal. When you install it, it should make it happen. If it doesn't, then you might have to fix your environment variables. Again, that's one of the things we can sort of check. And so in this case, I verified that, let's see, can I make this bigger? All right. So now Java is compiled. It's compiled and interpreted. So what the heck does that mean? All that will be revealed. But the Java compiler is called Java-C. And then what I want to do, I'm going to make a directory called build. And the reason for that is because that's when we start using NetBeans, that's going to be where they put stuff. Okay, so Java compiler is called Java-C, and I need to give it the name or names of Java files. And so the name of the files are, well, in this case, I have one file. It's called hello cs2173.java. And then now notice that I'm doing it from the directory above the package directory that it's in. And what that would do, and then what this does is this says it's going to compile this to something called class files, and it's going to put them in this directory called build. At least that's the plan. So over here, now notice that here's the build directory, and then here, this is what it just created. the CS2173. Oops. And then notice it's got a little coffee cup there. Okay, so that's the compiled, those are called bytecodes. And then to execute them, I need to direct it to this build class path. And the Java, the command called Java, this will invoke what's called the Java virtual machine. And I need to give it the name of the class that has that main method in it that I wrote before. In this case, it's the one that's right here. Why? Because I can have many different classes that have this main thing in it. So in the same project, I can have lots of different ones, and you'll see how that works. So this actually runs it. Now notice that there's a dot instead of a slash here, and that there's no Java extension. So what does that mean? That means that the Java virtual machine has as its main argument the name of a class that has been compiled, and it needs to find that compiled class. So when I run this, we see that it actually prints what I had done here. Okay, so what does it take just in order to do this? You know, why this is based on the Hello World, which was invented by the folk who wrote C back in the 1960s at Bell Labs. Actually, I remember after, when I got my master's, a number of my fellow students got jobs at Bell Labs, and I remember meeting with them sometime later. We were all hanging out, and they were saying, "Hey, there's this language you got to learn." I say, "Well, what's it called?" They say, "It doesn't have a name, just a letter. It's called C." I go, "C? What kind of language just has a letter?" I mean, anyway, so they had it all together. Anyway, so yeah, so why do this? Well, think of what it takes in order for all this to happen. This is going to happen only if I have the Java installed. It's going to happen only if I've correctly written a program that's going to work. And this is a very much an outlier. In other words, a program that works the first time that you write it, that usually doesn't happen. So if that's your experience, when you write something and it doesn't work, that's what happens. That's just, get over it. When I was first learning, this is back in the Fortran days, I would, because it was such a pain to type out these cards, you had to punch the holes in the cards with this key punch thing. And, then there was a lot of demand for that. So you had to kind of go and wait and kind of get it. So you had to go there and you wouldn't sit down and start coding. So I'd write stuff out. So I remember, write pages of code. And of course, my expectation was I would write all this code, put it into cards, put it in, it would work perfectly, go home. Never happened. Never happened. And the same thing now. Now that cycle is much accelerated. So we can sit there, we can sort of type something, and then in NetBeans, it's just you type something and you run it. You immediately see the errors. In fact, you get the errors even before you run it. So, and that's a good thing. That's a great thing. But what it took Java to be available. It took a program that didn't have any bugs in it, and that's why you just do the hello, because it's like you're printing something to the console. What could possibly go wrong? Actually, a lot of things. But and in order, so what this means is I can confirm that Java's working, and that it can actually run. Okay, and that it takes a bit of stuff to do that. Okay. So that is that, and I thought I was recording.